You are at cruising altitude, 35,000 feet up, and suddenly total engine failure. The cabin just goes completely quiet. Do you simply drop out of the sky?
I mean, that is literally the ultimate nightmare scenario, right?
Mm.
For anyone who dreads flying.
Right, exactly. Well, we are actually going to answer that exact scenario and the physics of why you really shouldn't panic in just a couple of minutes. Welcome to this deep dive into the architecture of aviation safety.
Yeah, today our mission is to basically soothe the nervous traveler in you. We're going to take those quiet, gripping fears we all have in the departure lounge and, dismantle them using cold, hard technical safety facts.
Which is so needed because the author perfectly captures that feeling of dread early on. Like a nervous traveler confesses their biggest fear is that once you are up there, there's just nowhere to go.
Right. You feel trapped.
Exactly. Trapped in a machine and, well, machines break. It's a totally rational fear if you think of an airplane like your car. I mean, if my car's axle snaps, I have to pull over.
But aircraft engineering fundamentally rejects that logic. They use redundancy. And we aren't just talking about, like, having a spare tire in the trunk.
Right, it is way more advanced than that.
Oh, absolutely. We're talking about active simultaneous redundancy. So take the hydraulic systems that control the flaps. A commercial jet usually operates with three completely independent hydraulic networks.
Wait, three of them running at the same time?
Exactly. If a line gets severed and one bleeds out, the other two don't even need to be switched on. They are already carrying the load seamlessly. Even the flight computers use this voting system.
The voting system, how does that work?
So three separate computers continuously calculate the flight path. If one glitches and disagrees with the other two, it gets outvoted and ignored.
That is wild. But let me play devil's advocate here for the doubting Thomas listening to this right now. No matter how many redundant computers you have, humans maintain them.
Right.
Mechanics get tired. Doesn't the human element basically guarantee eventual failure?
You would think so, but that is exactly why the redundancy extends to the human procedures on the tarmac. A single mechanic doesn't just check a box and call it a day.
What do they do instead?
Well, the ground handling crew does a physical walk-around, then engineers run diagnostic software tests, and finally, the pilots perform their own independent physical checks.
So nothing is left to chance.
Right. It is a system of overlapping jurisdictions. A single human error is almost always caught by the next net.
That makes a lot of sense. And speaking of pilots, we are actually going to get to turbulence in just a second. I want to ask everyone to please keep watching until the end because a major perspective shift regarding turbulence is coming up next, and it will permanently change how you handle a bumpy flight.
You really will.
But before that, I want to talk about those pilots. If the automation fails, they have to take over.
And the source points out that they don't just learn to steer. Pilots spend hundreds of hours in advanced simulators. They are constantly drilling for catastrophic, statistically near impossible failures.
It strikes me that commercial pilots are basically high-performance athletes. Like they are practicing for a sport they hope they never have to play.
That is a great analogy. The entire goal of that training is to completely bypass the human startle response.
Right, because you don't want them freezing up.
Exactly. When an alarm blares at 30,000 feet, they don't pause and think, what do I do now? The emergency procedure is already executing through pure muscle memory.
Okay, so the plane is this flying fortress of backups, and the pilots have nerves of steel. But then you hit a storm, the cabin starts shaking, dropping, rattling. I mean, it feels terrifying.
It does, but only because our brains misinterpret what is happening. The source explains this beautifully by asking us to look at the physics. Air is an empty space. It is a fluid, just like water.
Okay, so the plane is resting on this fluid.
Yeah, exactly. When a plane is flying, it is resting on a dense body of moving fluid. Turbulence is just the plane riding over uneven currents or, waves in that fluid.
So it is essentially like a boat chopping through rough water. Or maybe a car driving over potholes on a dirt road.
That is the perfect way to visualize it. It is uncomfortable, and yeah, it might spill your coffee, but the road itself isn't going to swallow you. Planes are built to withstand far more stress than turbulence can actually deliver.
Which brings us perfectly back to that open loop, our opening question. Cruising altitude, total engine failure.
Yeah.
What actually happens?
You glide. You don't fall because those wings are still moving through that dense fluid. A commercial jet has a glide ratio of roughly 18 to 1.
Meaning for every mile of altitude it loses, it moves forward 18 miles.
Exactly. From 35,000 feet, that gives the pilots over 100 miles of forward distance to find a runway, restart the engines, or coordinate a safe landing. And all those redundant backups keep them in full control the whole way down.
It really reframes the whole experience. We only hear about the rare anomalies. Thousands upon thousands of flights land safely every day because safety is a deliberately built system.
Absolutely. It is engineered to keep you safe.
Which leaves me wondering something else. As AI and automation get even more advanced, will we eventually see a day where human pilots are considered the riskier element in the cockpit rather than the ultimate failsafe? It is definitely something to chew on next time you are sitting at the gate.
Oh, that is a really fascinating question to take with you on your next flight.
Well, thanks everyone for your time today. Be sure to revisit the King's Academy feed for more knowledge and deep dives like this. Please let us know your opinion in the comment section on our platform, and as always, we read all posted comments and reply as soon as possible.